Okay, in this video we're going to be covering section 5.1, but since it's the beginning of unit 3, let's go ahead and go over the unit reference sheet. We have the unit circle, we have the equations and formulas that we'll need for chapter 5, and then here would be the equations and formulas that we'll need for chapter 6. So we'll be using this a lot. Make sure to have a copy of this as well. Okay. Let's go ahead and start with 5.1. Okay. All of this information here we've already talked about. Okay. You need to know all of this information. I've only shown you this one, which is similar to x squared plus y squared is equal to 1. Okay. But these are going to be the other ones that we can derive from this. Okay. And I'm going to show you how. All right. Let's go ahead and do that. If we know that sine squared x plus cosine squared x is equal to 1, and remember this is the same thing as y squared plus x squared is equal to 1 using the unit circle. Okay, this is a right triangle. Here's your x, here's your y, and here's 1. Okay, Pythagoras identity. How do we get the other two trig functions? This one here and this one here. Let's start with the first one. Okay, so if I divided everything by cosine squared, okay, what is sine over cosine? Hopefully you said tangent. Plus cosine over cosine is equal to 1 over cosine is secant squared. Okay, this equation is exactly the same one that we see here. So how do you think we get this equation? Well, if we divided everything here originally by cosine, then it makes sense if I go ahead and divide everything now by sine. So let's do sine. Sine over sine, that's going to equal 1, plus cosine over sine, that's cotangent, is equal to 1 over sine, which is cosecant. This equation is the same one that we have here. Okay, so as long as you know the first one, you should be able to derive the other two fairly easily. This is definitely going to be the hardest unit, so make sure to spend time working on these types of problems. Okay. Over here, we're going to simplify the expression, write the final form with no fractions. So in other words, what we're doing is we're just simplifying it to a single trig function or a number. Okay. So the first thing I'm going to do here is look at the individual trig functions. Here I have cosecant. That's the same thing as saying 1 over sine. Cosine is the same thing as just saying cosine times cosine. And then secant is the same thing as saying 1 over cosine. If you notice here, one of each of these cosines, they can cancel out. It just makes 1. And then now cosine over sine is cotangent. Okay. Number 2, break them up. I'm going to go ahead and write it like this. I'm going to do cosine squared x, 1 over sine, and 1 over cotangent. So I'm not changing anything yet. I'm just writing what this is equivalent to. Now I'm going to go ahead and break this up. Now 1 over cotangent is the same thing as tangent. So I'm going to go ahead and change this to tangent. And I'm going to leave the other two as it is. Okay. Now tangent is the same thing as sine over cosine. Okay. And the other two, I'm going to break up this cosine into 2. Okay. Now I can cancel sines with sine, cosine with cosine. So my final answer is just cosine x. All of this equals cosine x. I'm going to go ahead and box these. Okay. There's a lot of different ways you can do it. So if you saw a different way to do this, that's completely fine. Okay, this is just one method. All right, next one we have secant squared divided by tangent squared. Okay, minus 1. Now, anytime you have a fraction with a whole number, you need to make it a common denominator. So all I'm going to do is change the 1 so it can have a common denominator. I'm going to use secant squared x over tangent squared x minus tangent squared x over tangent squared x. Okay, now I can combine my numerators and keep the same denominator. So now I'm going to have secant squared x minus tangent squared x all over tangent squared x. Okay, now this is where our Pythagorean's identities come into place. Secant minus tangent. If I go back up here and I see here's my secant, what if I subtract tangent on the other side? If I subtract tangent from both sides, I'm going to get secant squared minus tangent squared. And that would just be equal to 1. Okay, so this entire numerator is just equal to 1 over the denominator, tangent squared x. Well, 1 over tangent is the same thing as cotangent. But since we have 2 of them here, we have cotangent squared x. And that's going to be your answer for number 3. Okay. For number 4, what we're trying to do is factor out something that's in common. If you can look here, you can see cosine is common to both of these terms. So if I factor out a cosine, I'm left with a cosecant squared x minus 1. Okay, so if I multiply it or distribute it back in, you'll get the same thing as you have in the numerator. For the denominator, you can do exactly the same thing. Cosine is in common to both, so I'm going to factor out a cosine, and I'm left with cosecant x plus 1. Okay, now you can see your cosines can cancel, and cosecant squared minus 1 can actually be factored out again. If you remember this from college algebra, this is what we call the difference of perfect squares. This is the same thing as cosecant x plus 1 times cosecant x minus 1. Okay? If we're dividing that by cosecant x plus 1, we can see that these two terms cancel, leaving our final answer as cosecant x minus 1. Okay, now this is a little bit different than the others, but notice that there's only one trig function here. The other one is a number, and that's okay because this is as simple as it can get. Okay, let's keep going. Verifying trig functions, these are going to be a little bit different. All we're doing in these cases is we're making sure that one side of the equation matches the other side of the equation. Okay, we're going to actually prove it. So on this one, the first thing you see inside the parentheses is your negatives. We have to know our odd and even functions here in order to determine if we can eliminate those negatives or if we have to keep them and then just pull them out. So let's start with cosine. Cosine, is that an odd or an even function? It's an even function. So when it's an even function, we can just eliminate the x and we're left with cosine x. Okay? Secant is the reciprocal of cosine, so that means secant is also an even function. I actually did two things here. I eliminate the negative because secant is an even function, and then I wrote secant as 1 over cosine. Okay? Plus, okay? Now here, tangent is an odd function, which means the negative has to come out. So this would be negative tangent x. And cosecant is an odd function, which means the negative also has to come out. Okay? Two negatives make a positive. So I'm going to rewrite the terms tangent as sine over cosine and cosecant as 1 over sine. Okay, now we can go ahead and eliminate. These two will cancel, so I'm left with just a 1 here, plus cancel, cancel, 1 over cosine. 1 over cosine is the same thing as secant. Okay, so that's going to be your answer. Can't simplify it more than that. And you can see that this matches this. Okay, so since they match, we verified that this is an identity. Okay, number 6. Here you can see that we do not have a common denominator, so what we're going to do is go ahead and use a common denominator. Algebra, and we say we had 1/3 plus 1/2. What did we have to do? Remember, when we are using the common denominator, we use the other denominator to kind of help us. So if I did 2 over 2, I would use the 3, and I would do 3 over 3. Okay? Multiply, you get 2 over 6 plus 3 over 6. Okay? And then you can add them once you have your common denominator. This would be 5 over 6. Okay? Let's go ahead and do that using these trig functions. I'm going to go ahead and do it like this. I'm going to rewrite our original term. Okay? Now what I'm going to do is I'm going to use this function and I'm going to multiply it over here. Okay, I didn't leave myself a whole lot of room, but I'm going to go ahead and just do secant x plus tangent x. Secant x plus tangent x. Okay, I'm going to take this denominator and I'm going to multiply it on this side. Secant x minus tangent x. Secant x minus tangent x. Okay, so now I can go ahead and multiply. Well, this means it's the difference of perfect squares. So if you remember, you only multiply the first times first and the last times last. So I would get, for my denominator, and here you're doing the same thing. You're multiplying first times first, last times last, and you can see now we have a common denominator. So I'm only going to write it once, which would be secant squared x minus tangent squared x. Okay. Now I'm going to go ahead and multiply this times 1, which is just going to get me a secant x plus tangent x, minus applies to the entire thing. So if this had parentheses in it, I'm going to be distributing the negative into both of these. So I'm going to have a minus secant x, negative times negative, positive tangent x. Okay. Now I can simplify inside. If you see here, this and this, they will cancel out for each other. So I'm left at the top with 2 tangent x. Okay. In the denominator, we have to see what is secant squared x minus tangent squared x. If we go back to those identities, okay, secant squared x, and if I subtract the tangent squared x, I'm left with that equaling 1. So what I'm going to do here is just say that this is the same thing as 1. So our answer here will just be 2 tangent x. And if you notice, it matches what we originally have. So we're saying, yes, this is a identity. Okay, right. Let's go on to the next one. Okay, number 7, we want to make this side look like this side. That was the other thing I forgot to mention. When you're doing the verifying the trig identities, we're always going to start on the left-hand side and make it equal to whatever's on the right-hand side. Don't ever start on the right-hand side and then go to the left. Okay. Here you can see we're kind of a little bit stuck. There's no way that we can manipulate the denominator here because these are not part of our Pythagorean's identities because they're not squared. Okay, and then the cosine, it doesn't go to each one of these because there's a plus here. The only thing we can do here is multiply this fraction by the conjugate of the denominator. So let's go ahead and do that. Okay. So I'm going to go ahead and rewrite this in my regular pen color. Okay, and what we're multiplying this by is secant x. Remember, a conjugate means all you're doing is changing the sign in the middle to be the opposite. So if it's plus, we're going to use minus. If it's minus, we would use plus. And I'm going to multiply it by a unit of 1. So if you remember, now what we can do is difference of perfect squares, first times first, last times last. That's going to be secant squared x minus tangent squared x. In the numerator, all I'm going to do is go ahead and write this out. I'm going to say cosine x 1 over cosine x minus tangent is sine x over cosine x. Okay. If you remember, secant squared minus tangent squared, if you go back over here, secant squared minus tangent squared is equal to 1. So the denominator here is the same thing as 1. I'm just going to go ahead and write it like that. And then I can go ahead and distribute this cosine into the parentheses. So when I do that, what I'm going to be left with is cosine over cosine minus cosine times sine over cosine. Okay, now I can say cosine over cosine is the same thing as 1. And the cosines here also cancel. So I have 1 minus sine. And that's going to be our answer. Same thing as what we have over here. Okay. Next one over here, you can see again we don't have much we can work with, so what I'm going to do is use the conjugate again. I'm going to multiply everything by cosecant x plus 1. Okay, so we're going to do that. So I'm going to write the equation just like I originally have it, and then now we're going to use a different color for the conjugate. Okay, so cosecant x plus 1. Cosecant x plus 1. Okay. First times first, last times last. That's going to be cosecant squared x minus 1. And then in the numerator, it's going to be cotangent. I'm going to go ahead and just write it as cotangent cosecant plus 1. Okay. Cosecant squared minus 1. Let's go back to those identities. Cosecant squared, if I subtract 1, I'm left with a cotangent squared. So all of this is going to be equal to a cotangent squared. Okay, I have a cotangent in the numerator. So one of these cotangents will cancel one of the cotangents in the denominator. Okay, so this will cancel with one of these. So now what I'm left is just a cosecant x plus 1, which is my numerator here, and then just one cotangent, which is my denominator here. So this is another identity that matches. Okay, for number 9, you're not going to have log problems on your homework or your test, but I do include it here because when you get to calculus, you will see logs. We don't have a whole lot of logs in pre-calculus, but I like to keep the problems that we do have. I want you to be able to remember the log properties. So if you remember, these are natural logs, and this is in an expanded form. So how can I simplify this form? Is I'm going to write it as 1 log, and then if you remember, if it's a positive, it's the product. If it's a negative, it's the quotient. So here you can see sine is positive and cosecant is positive, so these two will go in the numerator. So I'm going to have sine x times cosecant x. Because this is a negative log, the cosine goes in the denominator. So cosine x. Okay. All I have to do now is simplify. Cosecant is the same thing as 1 over sine, so I'm going to write it like this. Sine x over cosine x, 1 over sine x. These two will cancel. And then 1 over cosine is the same thing as secant. Now I verified that these are identities. Okay, number 10 here. Verify the equation is by, okay, so on this particular one, we're going to be doing both sides of the equation independently. So I'm only working on this side, getting a single trig function, and I'm working on this side and getting a single trig function. You're not going to have homework problems like this, but the reason I left it in here is so we can continue to practice. So let's go ahead and start with the first one. So what's in common with these two terms? Hopefully you said you can factor out a sine, so let's do that. I'm going to take out a sine, and inside I'm left with the 1 minus sine squared divided by cosine squared. Okay, what is 1 minus sine squared equal to? Go back to your identities up here. Okay, 1 minus sine is equal to cosine squared. So I'm going to have this equal to cosine squared. Okay, so I'm going to do it like this. Sine x cosine squared x over cosine squared x. These two will cancel, which leaves me with just a sine x on this side of the equation. Okay, I'm going to go ahead and manipulate the other side of the equation and see if I can get the same trig function. Okay, so let's go ahead and work on this side over here. All I'm going to do is go ahead and break it down. I'm going to use sine squared x over 1 times secant is the same thing as 1 over cosine. So I'm going to have 1 over cosine. And then this is going to be the same thing as 1 over tangent x. Okay. Now what I'm going to do is I'm going to go ahead and say, well, there's two sines here and there's 1 cosine there. That means I can go ahead and break it up. I can say sine x times sine x over cosine x times 1 over tangent x. Okay, now what I can do is say, hey, this is the same thing as tangent. So I'm going to say sine of x times tangent x times 1 over tangent x. Our tangents cancel, leaving me with just sine x. So now I have sine x on both sides. I've manipulated the equation and say, yes, these are identities. Okay, let's go on to the next page. So on this next part, all we're doing is writing an algebraic expression as a trig expression. Okay, so what we're going to do on number 11 is we're just going to substitute. This right here tells us what quadrant we need to be in. Theta to be between 0 and pi over 2 makes it going to be in quadrant 1. So the first thing I'm going to do is go ahead and use my x, and I'm going to substitute what x is equal to, okay, into my equation. So let's go ahead and do that. Here, we're going to have square root 16 minus, substitute this for x, I'm going to say 4 sine theta squared. Okay, now this square applies to both of these terms. So when I go down again, I'm going to have 16 minus 16 sine squared theta. Don't put the square on the theta, it needs to go to the trig function. Okay, now if I look at this, I can say, well, 16 can be factored out of both. So here I can have 16, 1 minus sine squared theta. Well, what is 1 minus sine squared? Hopefully you go back to your Pythagorean's identities and say 1 minus sine squared equals cosine squared. So from there I'm going to go ahead and put 16 times cosine squared theta. Okay. Now if you remember your radical rules, anytime there's a multiplication here, we can actually break this up into 2 parts. I'm going to go ahead and do that like so. Square root of 16, 4. Square root of something that's squared, well, it's just going to be cosine theta. Okay, and that's your answer. Cosine is positive in quadrant 1, so this value is going to be positive. Okay, let's try it again. Just substitute wherever you have your x, substitute what your x is equal to. Put parentheses anywhere you see a squared. So this would be 3 tangent theta squared plus 9 over 3 tangent theta. Okay, this applies to both. So here we would have 9 tangent theta squared plus 9 over 3 tangent theta. Okay, factor out a 9. You get tangent squared theta plus 1 over 3 tangent theta. Okay, and then tangent squared theta plus 1, go back to your trig identities. Tangent squared theta plus 1 is equal to secant squared. Okay, so we're going to go ahead and everything in the parentheses is equal to secant squared. So I'm going to go ahead and put secant squared theta. It's still in a square root. And then you have 3 tangent theta. Okay, let's break this part up. Square root of 9 times secant squared theta divided by 3 tangent theta. Okay, this is going to be 3 secant, because the squares cancel with the square root, over 3 tangent theta. 3's will cancel, so secant over tangent will, if you don't remember, secant is the same thing as 1 over cosine. So secant theta times cotangent theta, because 1 over tangent is the same thing as cotangent. And then let's break those up. Secant is going to be 1 over cosine times cotangent, which is cosine over sine. Those two cancel. 1 over sine is the same thing as cosecant theta, and that will be your solution. Okay. All right, that ends the notes for 5.1. You have to practice, practice, practice. It will take some time, so please get started on this section as soon as possible. Thanks.